Finite differences and interpolation. Today we will solve the examples based on the Newton's forward interpolation formula. Before we get started, we'll understand what is interpolation. Interpolation is the process of computing intermediate values of a function from a given set of tabular values of the function. What does this mean? This means that we are given the values of x, and corresponding to those values of x, we also have the values of y, where y is equal to f of x. So suppose we have x naught and end value is xn, then we'll also have y naught till yn values. And by doing interpolation, we'll find the value of y for some value of x which is equal to xi. Now let's see the formula for the Newton's forward interpolation. So for the Newton's forward interpolation, we have f of x is equal to f of x naught plus r into delta f of x naught plus r into r minus 1 upon 2 factorial into delta square f of x naught plus r into r minus 1 into r minus 2 divided by 3 factorial into delta cube f of x naught. Same way the next term will be r into r minus 1 into r minus 2 into r minus 3 divided by 4 factorial into delta raised to 4 f of x naught. So this is how we find the value of r, which is x minus x naught divided by h. If we are having 4 values of x and y, then the formula will continue till delta cube f of x naught. And if we have 5 values of x and y, then the formula will continue till delta raised to 4 f of x naught. This will be much more clear to you while we'll solve the examples. The first question is, find a polynomial which takes the following values. So the values of x and y are given to us and we have to find the value of f of 5. Now here in the question it is not mentioned that we have to use the Newton's forward interpolation formula. But as 5 lies between 4 and 6, that is, the value of y is near the initial tabulated value, that is, it is near x naught. So we'll use the Newton's forward interpolation formula. If the value would be 9, that is, it lies between 8 and 10, then we would have used the Newton's backward interpolation formula. So here our x naught is 4 and h is the difference between the values of x, which is 4 and 6, 6 and 8 and 8 and 10. So it is 2. Here we'll have equal intervals. R is equal to x minus x naught divided upon h. So our x is 5 and x naught is 4. So we'll get r is equal to 1 by 2. Always remember that the intervals will be equal, then only we can use the Newton's forward interpolation formula. Now we'll create a table like this. If you are writing in a lined notebook, then always have a habit of writing one value of x, then leaving one line. So as we have 4 values of x and y, we'll go till delta cube f of x. Now as you can see this 4, 6, 8, 10. After you write 4, leave one line, then write 6, again leave one line, then 8, leave one line, and then 10. Corresponding to those values of x, write the values of y. And then here we'll calculate the delta f of x. That is the difference, 3 minus 1. Wherever you have left those blank spaces, that is the blank line, there only you will write this. So it will be, second one will be 8 minus 3, and third one will be 16 minus 8. Simply we are just taking the difference. Now again here we'll take the difference of these two values, that is 5 minus 2, which is 3, and then 8 minus 5, which is 3. And again you will write between this, between the values of 3 and 3. So it will be 3 minus 3 equal to 0. So now we can just put all of these in our formula. F of x is equal to f of x naught plus r into delta f of x naught plus r into r minus 1 upon 2 factorial into delta square f of x naught plus r into r minus 1 into r minus 2 divided by 3 factorial into delta cube f of x naught. So now here f of x naught is 1, r we have already found, which is 0.5. So 1 plus 0.5 into our delta f of x naught is 2, the first value in the table of delta f of x. Then the second value in the table of delta square f of x will be your delta square f of x naught, and the third value, that is the first value in the table of delta cube f of x naught, will be your delta cube f of x naught. So it's simple, just input all of these, 0.5 into 0.5 minus 1 upon 2 factorial into 3 plus delta cube f of x naught is 0, so we'll just put it 0. Now on solving this, we get 1 plus 1 plus 0.5 into minus 0.5 divided by 2 into 3. And this comes out to be 1.625, which is equal to 13 by 8. Let's see another example. So here we have to estimate the number of students who obtain the marks between 40 and 45. Now this table is of x is the marks less than x and f of x are the number of students. We have to obtain the marks between 40 and 45, that is we are interested to obtain the marks less than 45. Now as we know that 45 lies between 40 and 50, that is the value of y is near x naught. So we can use the Newton's forward interpolation formula. So here as we are interested in 45, x will be 45, x naught will be the first value which is 40. And what is h? It is the difference between these intervals, which is 10. Now r is equal to x minus x naught divided by h, which will be 45 minus 40 divided by 10. So it will be 0.5, or we can say 1 by 2. Now we'll create a table. Here as you are having 5 values of x, so we'll have to go till delta raised to 4 f of x. So our first column will be for x, second column for f of x, third one You can even write it as delta y, or you can write it as delta f of x, then delta square y, delta cube y, and delta raised to 4y. Y is equal to f of x. Now just put the values of x like this, leaving one line in between, and also the values of f of x. Now we'll just take the difference. 73 minus 31, which is 42. 124 minus 73 is 51. 159 minus 124, which is 35. And 190 minus 159, which is 31. Now again we'll take the difference here. The difference will be between these two values, which is 51 minus 42 is 9. 35 minus 51 is minus 16. 31 minus 35 is minus 4. Now the difference between minus 16 minus 9 is minus 25. Then minus 4 minus 16. Here don't get confused. It will be minus 4 plus 16. So here we'll write it as 12. Now 12 minus minus 25, that is, it will be 12 plus 25. So it will be 37. So this is how you have to create the table. You can even show these arrows from y till delta raised to 4y. Now the formula is f of x is equal to f of x naught plus r into delta f of x naught plus r into r minus 1 upon 2 factorial into delta square f of x naught plus r into r minus 1 into r minus 2 upon 3 factorial into delta cube f of x naught plus r into r minus 1 into r minus 2 into r minus 3 upon 4 factorial into delta raised to 4 f of x naught. Now here we have to find the value of 45. So it will be f of 45. Our first value is 31. So f of x naught will be 31. Then 0.5 is our r value. And what is delta y? We have created these arrows so that we can understand which values we have to take in delta y, delta square y, delta cube y, and delta raised to 4y. So this will be 0.5 into 0.5 minus 1 by 2 factorial into delta square y is 9 plus 0.5 into 0.5 minus 1 into 0.5 minus 2 upon 3 factorial into our delta cube y is minus 25. And then we have delta raised to 4y, which is 37. If you remember the formula, then it's very much easy to solve these questions, because all we need to do is just create this table and then input the values in the formula. And this table is also very much simple because the x and y values are already given to us. Delta y is the difference between the values of y. Then delta square y is the difference between the values of delta y. Delta cube y is the difference between the values of delta square y. Now on solving this, we'll get it like this. 31 plus 21 minus 1.1250 minus 1.5625 minus 1.4453. That is, it is 47.8672, which we can take it as 48. So we have found the number of students having marks less than 45, which is equal to 48. We also have the number of students having marks less than 40, which is 31. Now what we have to find is the number of students who have marks between 40 and 45. So that is very much simple. We'll just subtract the number of students having marks 40 from the number of students having marks 45. So it will be 48 minus 31, which is equal to 17. So this is how you can solve the examples based on the Newton's forward interpolation formula. In the next video, we'll solve the examples based on the Newton's backward interpolation formula. Thank you.